Hi all, um, my name is Balamurgan Nagarajan. இந்த வீடியோவில் வந்து ஜீரோ நாலேஜ் பற்றி பேச போகிறோம். ரொம்ப டெக்னிக்கலாக பேச போகிறது இல்லை, ரொம்ப சிம்பிளாக என்னென்ன ஸ்டெப்ஸ் இருக்குது, ஹவு டு இம்ப்ளிமெண்ட் இட் அப்படின்னு பார்க்க போகிறோம். ஐ நீட் டு கிவ் கிரெடிட்ஸ் டு பெல்டெக்ஸ் பிளாக்செயின். ஒரு 2 days பேக் அவங்களோட ட்விட்டர் ஹேண்டிலில் தே போஸ்டட் லைக் தேர் டூயிங் சம் ரிசர்ச் ஆன் ஹவு டு வெரிஃபை த ஏஜ் யூஸிங் ஜீரோ நாலேஜ். நான் அவங்களோட ஒயிட் பேப்பர் ரீட் பண்ணி பார்க்கும்போது தே ஆர் யூஸிங் எ புல்லட் ப்ரூஃப் டைப் ஆஃப் ஜீரோ நாலேஜ் ப்ரூஃப். பட் இந்த கேஸில் we are going to use snark. Snarkங்கிறது இட்ஸ் அ டைப் ஆஃப் ஜீரோ நாலேஜ் ப்ரூஃப். We are going to use a programming language called Noir. So it's a DVL, domain specific language. ஸோ எஸ், என்னென்ன ஸ்டெப்ஸ் இருக்குது, என்ன இந்த 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 வீடியோவில் என்ன கவர் பண்ண போகிறோம்னா, what are circuits, how to build a circuit, what is witness, how to generate a witness, and how to generate a proof from the witness, how to generate a verification key, what is verification key, and how to verify using this verification key as well as the proof that's been generated from the prover side. இங்கே வந்து there are two parties. One is the verifier, one is the prover. So prover role என்னன்னா, they have to prove that they know something without revealing the exact information or exact secret, right? In our case, it's going to be the exact age. So என்ன ப்ரூவ் பண்ண போறோம்னா, we are going to prove that my age is more than 18, but I'm not going to be pretty easy. ஏன்னா சர்க்கியூட் வந்து ரொம்ப ஈஸியாக இருந்துச்சு. Let me explain you, right? Where is my VS Code? Okay, this is a simple circuit. We are taking two parameters, the age and then the threshold, and we are going to convert into U64, unsigned integers 64 bits. Why? Field does not have the ordering. So if you are comparing two properties, then you have to convert from field to unsigned integers. That's what we are doing over here. அவங்களோட டாக்குமெண்டேஷன் பார்த்தீங்கன்னா you can get a better idea about it. But at the end of the day, what we are going to assert, we are going to assert my private input. Here you can see there is no pub keyword, which means my private input is greater than the public input. What is the public input? That's going to be the 18, the threshold, the constraint, right? That's what we are trying to prove. And let's go step by step. From the start, I have created a notes file. First, we have to do certain things. First thing is we have to generate a prover.toml file. The Noir check. This is the command that will generate this prover.toml. And then you have to pass this private key, private input as well as the public input. Let's pass 25 as my age, and I'm going to set a threshold of 18. So these are the two parameters, input parameters that we are going to pass into this circuit, right? Let me save this file and let me go back to notes.md. Now we are going to execute. Nora execute does two things. What are the two things it's going to do? One, it's going to convert, or it's going to compile the circuit into the bytecode. And the second thing, let me make my screen bigger. Yes. That's the first thing that's going to be done. And then the second thing is it's going to generate a witness. What is witness? It changes according to the context, but to be specific, it is either the input that you are passing to the circuit or the intermediate steps that are required to verify that the constraint passes, right? In our case, what are the inputs that we are passing? The age as well as the threshold. The age is going to be the private input, and then the threshold is going to be the public input. So using this input and the bytecode that is being compiled, that's been derived from compiling the circuit, we are going to generate the witness, which is required to generate the proof. So now we are going to generate the witness, right? Let's go for it. So this is the command. This does two things. First thing, compile, and second thing, generate the witness. So it creates a target folder over here. GZ, this is the witness that's been generated from the bytecode as well as the prover.toml, the input parameters that we are passing to the circuit. And inside this JSON file, you can find the bytecode. Now, what is the second thing? We have to generate a verification key. This verification key is a dependency For generating the proof, here you can find the VK. VK stands for verification key, and then the verification key hash. Once this is done, then we are going to generate a proof, right? Uh, so what is the command? BB stands for Bug. It's a type of backend. This Noir language, right? This circuit is being compiled into ACIR, which is further being processed by this BB Bug. It's a backend tool that is developed. So this is going to take the bytecode that's inside this ageproof.json file, and also the witness that we have generated uh, using this Nova execute command. So let me run this. This will generate a proof. Over here you can see the proof and then the public input. In our case, the public input is going to be the threshold. Now we have the proof, the public input, and then the verification key. So here on, uh, think of you are a verifier, right? I'm not going to give my exact input, but I'm going to give you the proof and also the verification key. Okay, that's more than enough to verify that my age is more than the threshold, which is 18, without revealing the exact input, which is this command bb verify, pass the key, the verification key that we have generated, along with the proof that we have generated. So I'm not going to give my age, rather I'm going to give my proof that I have computed. So this is the final command that's been run by the verifier, not by the prover. By the verifier. The prover is the one that's going to generate the proof and hand over this proof to the verifier. Verify using this proof. Let me click enter. You can find that the proof verifies successfully. They are using a scheme called the ultra hunk. This is by default. You don't want to worry about it right now. So that's how you can prove that your age is greater than 18 without revealing the exact age. We have to generate the witness, from the witness generate the proof, pass this proof along with the verification key to the verifier. The verifier uses this verification key along with the proof to verify that your age is more than the threshold, which is 18, without revealing exact 25-year age. I think that's clear. What if, let's do one thing. What if we are trying to generate a proof which does not satisfies this constraint? What is the constraint? My age should be greater than the threshold, which is 18. Let's try to do something like 17, right? Let me save this pivot.toml, then clear this terminal, go back to the notes.md. Let's try to generate a witness from the input that does not passes the constraint that's been mentioned inside the circuit. Let me run this. It does not pass. You can see the error failed constraint. So which means that the input that we are passing over here does not clears this line. Okay, and this constraint failed. So it's not at all possible to create a witness uh, by passing a wrong set of input. That does not satisfies the constraint. I hope this clear. I hope this is clear. Again, thanks to the credits who inspired me to do this to do this project. Thank you all for watching this. Thank you so much. See you on the next video. Peace.